This is the last section of chapter 5, section 5.5 on absolute value inequalities. So let's get started here. There's two cases to consider, just like we did with absolute value equations. So the first one here, the inequality, the absolute value of x is less than 3, actually means that the distance between x and 0 is less than 3. So you can see that graphed on the number line. So if I'm at 0 on the number line and I go 3 to the left or 3 to the right, I am within -3 and +3. So that solution set, like you can see here, is written as that double inequality that we saw from the previous video. -3 is smaller than x is smaller than 3. So it's somewhere in between -3 and +3. Number 2, the absolute value of x is greater than 3, means the distance between x and 0 has to be greater than 3 units away. So you can see I went out to -3, and beyond that to the left would be values that are more than 3 units away from 0, and similar on the right. If I went out to 3 and then I go beyond 3, that gives me values that are greater than 3 units away from 0. So you'll see the solution set as the or statement in between both of those. So whenever we solve these, we're going to go through one intersection and one or union. They need to consider case 1 and case 2. So you need to solve each inequality, then graph the solution set. So on both cases, remember from equations, you want to drop the absolute value bars. Okay. So on this case 1, all we do is drop the bars and we solve it. And it's a nice, easy one step. I subtract 2 from both sides, and you get m is smaller than 9. And this is a less than sign, so this is going to have the word and in between. Then we have to do case 2. In case 2, the only thing that changes, I call it the negative flip case, because you're going to flip the sign, the inequality sign. And then make what was the number on the right, like the 11 here, we're going to make that a negative and resolve it again. So I'm going to change my color. So instead of m plus 2 being less than 11, it's going to be greater than -11. So that's what I mean. The symbol flips and the 11 became negative. And we're going to solve this the same way. Subtract 2. M has to be greater than -13. So on my number line, when I represent these values, it has to be smaller than 9, and it has to be greater than -13. So if you think about that as a compound inequality, if we go least to greatest, x is going to be somewhere in the middle. It's going to look like this. I guess m is in the middle on these problems. So I'll change that variable to an m. So you need to go from -13 to a 9. So I'm going to count by 3s, I think. All right, so it has to be smaller than 9, so that means I'm in open circle on 9, and it has to be greater than -13. So -13 is about here, open circle, and it's going to be all the values that are in between this. So we just connect the two. So that is our intersection inequalities. Next up, we have the or statements. So that's a greater than or greater than or equal to. So this is going to have the keyword of an or in between our two cases. So case 1, again, drop the bars, just solve it as it is. 3n plus 6 is greater than or equal to 12. So we're going to subtract 6 and divide by 3. N is greater than or equal to 2. Or, so make sure you write the word or. And we're going to do case 2. So again, it's you flip the sign and the 12 becomes a negative. So 3n plus 6 is now less than or equal to negative 12. Subtract 6, divide by 3, n is less than or equal to negative 6. So this is our whole solution right here. N has to be greater than or equal to 2 or less than or equal to negative 6. So since these are even numbers, I'm going to count by 2's. All right, and you just have to graph both pieces on the same number line. So n is greater than or equal to 2 is a closed circle at 2, and including all the values to the right. And n is less than or equal to negative 6 is a closed circle at negative 6, and all the values to the left. So these will be or statements like the previous video. They go in opposite directions. And then we have to consider one other thing, these special cases. So when we talked about absolute value equations, the absolute value we knew was a positive number and it could never equal a negative number, so that's why it had no solution for that. But these you have to be careful on the sign that's the inequality symbol. So we're gonna take a look at both of these. So the left one, the absolute value of y minus 1 is smaller than negative 2. So remember, whatever this is, it's going to be a positive number. And they're saying this positive number is smaller than negative 2. Well, we should know that's not true because positive numbers are bigger than negative 2. So a positive number is never smaller than a negative number. You want to write that down. So this has no solution, or the empty set, the circle through the slash through it. On the other end, if I had the absolute value of this, again, it's going to represent a positive number no matter what's in there. But now I'm saying that positive number is bigger than negative 2, which is true. A positive number will always be bigger than a negative number. So this solution over here is all real numbers infinitely many solutions, that type of thing. So you have to really pay attention to what inequality sign is up there. All right, so you don't have to try any of these other ones in the notes. We will do these in class. So that's the end of your notes. Just try the Delta Math questions that I'll have for you, and we'll see you tomorrow.